Hi, I'm Melissa, and today I will guide you through building the Project A from Starter Kit Digital Hourglass. By only using a few components, LEDs and a tilt sensor, we can create a visual timer that will light up one LED every 10 minutes. A traditional hourglass has sand inside, and whenever we turn the glass, time starts running. In today's project, we will use the tilt sensor in the same way. The tilt sensor we have in the kit has a metal ball inside that will make a connection across two leads when tilted. The tilt sensor is a type of a switch that can have two values, open or closed, and we can read those values using digital read in our code. We will keep track of the time by using a function called millis, which handles time in milliseconds. Because we want to create a timer for an hour, we need to handle large numbers. For that reason, we're going to use a data type called long. The long data type can hold a 32-bit number. Other data types we can use are, for example, float with decimal numbers, string with text, and boolean when something can be only either true or false. I will explain more how the example sketch works, but first, let's create the circuit. Make sure your board is not powered. I have connected wires for power and ground here. I have also connected 5 of the LEDs here already, and I will add the last one the same way I connected these. Remember to check which one of the LED's legs is the long leg and which one is the short leg. Long leg goes to a digital pin and short to ground through 220 ohm resistor. Then I add the tilt sensor. Connect one of the legs to power and another to ground and a digital pin 8. The tilt sensor also needs a 10k ohm resistor. So now I have here the power and here the digital pin 8 and through resistor to ground. Now I can connect my board to the computer and upload the example sketch. First, we initialize all the variables needed in this sketch. We need to use the long data type for storing the previous time and time interval. In the setup, we can use a for loop to declare the LED pins as outputs, or you can declare each LED separately like you did in some of the previous projects. At the top of the loop, we store the time we get from millis function to a variable called current time. Then we check if the current time minus previous time is bigger than the interval. If true, we execute the code after the if statement and turn on an LED using digital write. After checking the time, we read what is the state of the tilt sensor. If the tilt sensor state is not equal with its previous state, all the LEDs are turned off and the previous time is set to be the same as current time. If you want to test that everything is working as intended, but you don't want to wait for 10 minutes to see the first LED light up, modify the sketch and change the interval from 600,000 to 1000, which is 1 second. Now, when tilting the breadboard, you should see one more LED lighting up every second. So far, we have used the USB port to power our board. But after uploading the program, we can also power the board using a battery, like this. Remove the USB cable and take the battery snap that is included in the kit. If needed, you can always cut off some of the insulation to make it fit the board better. Connect the snap part to a 9-volt battery and the loose ends to your Arduino board. Black wire to ground pin and red wire to V in, which means voltage in. When we upload a sketch to our Arduino board, it is stored there until we upload a new sketch and runs whenever the board is powered. With a battery, you can take your project with you wherever you go. In the next project, we will power a DC motor with a battery. See you then!